Understanding normed vector spaces, a key concept in mathematics. Hello, everyone. Welcome back to our channel. Today, we're diving into an interesting mathematical concept that has wide applications in various fields like physics, engineering, and computer science. We're talking about normed vector spaces. Whether you're a student, a professional, or just a curious mind, understanding this concept can open doors to deeper insights in mathematics and its applications. So, let's get started and unravel the mysteries of normed vector spaces together. Before we delve into normed vector spaces, it's crucial to understand what a vector space is. In simple terms, a vector space is a collection of vectors, which are objects that have both magnitude and direction. Imagine arrows of different lengths pointing in various directions. Each arrow represents a vector. Vector spaces follow specific rules, allowing you to add two vectors together or multiply a vector by a scalar, a real number, to get another vector. These operations adhere to certain axioms, like commutativity, associativity, and the existence of an additive identity, a zero vector that doesn't change any vector it's added to. Now, let's introduce the concept of a norm. A norm is a function that assigns a length or size to each vector in a vector space. It's a way to measure how big or small a vector is, based on its magnitude. The norm of a vector is denoted by v, where v is the vector. For a norm to be valid, it must satisfy these conditions. It is non-negative, meaning it cannot give a negative length. It is zero if and only if the vector is the zero vector. It respects scalar multiplication, meaning the length scales proportionally if the vector is scaled. It satisfies the triangle inequality. The length of the sum of two vectors is less than or equal to the sum of their lengths. A vector space becomes a normed vector space when a norm is defined on it. This means every vector in the space has a specific length according to the norm. Normed vector spaces allow us to discuss concepts like distance and angle between vectors, making them incredibly useful in fields that require precise measurements and calculations, such as physics and computer algorithms. The beauty of normed vector spaces lies in their ability to generalize the idea of distance and direction in mathematical, physical, and abstract spaces, providing a foundation for further concepts like inner product spaces and metric spaces. And that wraps up our exploration of normed vector spaces. We hope this video has illuminated this fundamental concept in mathematics and its significance in various applications. Understanding normed vector spaces not only enriches your mathematical knowledge but also enhances your ability to apply these concepts in real-world scenarios. Thank you for watching, and we look forward to seeing you in our next video. Keep learning and stay curious.